Good morning, everyone. Molo, Sawubona, Dumelang, Hu Itehani. I hope you're all ready for this workshop. A very warm welcome from me. So today we will be discussing one of the most important topics probably in your career, and this you need to learn how to do already at the honors or at the very early career phase, and this is how to choose a discipline and a topic for your studies, and also to how to select a mentor and a supervisor. Now you can first start by either selecting your supervisor and your mentor, or you can start by choosing a discipline. But of course, first you need to choose a topic and an area that you are passionate about. Remember, if you're not going to be passionate and really interested in this, you're going to struggle with your studies and to successfully complete it, because honors and postgraduate work, it's hard work, it's a lot of dedication, and you need to be passionate about what you do. So choose a topic and a discipline that you really like and that you see yourself developing your career in. Now, some people would choose a topic or a subject or a certain area in their honors, and then maybe they change later to another discipline or another study area for their master. So you don't have to stay in one discipline and then carry on with your career. And that many people change from one area to another. It's also important for you, if you change, for example, research areas, it's actually very good, because then you'd learn multidisciplinary skills. You learn skills in different research areas that can really benefit you in your future career. Then, as I already said, sometimes supervisors will already have a project for you. You have to discuss this project that they have, what it will entail, what is the expectations of you, how many papers you should publish already at the early career stage, etc., etc. So either way, first you can obviously choose your topic that you're interested in, or a supervisor will already have a topic for you, and then you can just jump into this. Now, besides a supervisor that will supervise you. This is the person that will ensure that you complete your thesis, that you submit your thesis, that the thesis is examined, and that you eventually get your career. So this will be your supervisor. But it's very important also for your career to choose a mentor. Now, this can be your supervisor, or it can be another person. And this is a person that helps you with your career progression, that you can go to if you have challenges, if you are worried about something, if you're unsure about something, or if you have some how can I put it, unkindness with your supervisor, then you can go to your mentor and ask for advice and guidance on how to handle such a situation. Or if you want also letters of support, you can also ask your supervisor or your mentor. But having a mentor, especially in science, is very important. And you can find mentors in your department. It can be a postdoc student. It can be someone that you trust and that you met at a conference. So there are many opportunities. Sometimes there's also programs where you can apply to have a mentor. So this is important for you to know about. So in this session, we'll basically be discussing how to choose a topic and a research discipline that you will focus on and that you'll do your studies in and eventually graduate with your honors degree. And maybe this topic is so interesting, you will further your master's and your PhD studies in this. Then we'll also learn more about research types or methodologies. This is also important. If you're in different disciplines, how to approach your research, what type of methodology you should use. Now, remember, there's lots of different research methodologies. For example, if you're in science, you will mostly do quantitative studies. If you're in medicine, there will be a lot of different study types. You can maybe do a retrospective review of patient files. You may be doing a clinical trial where you will be administering medication to patients, and then you will be testing their reaction to this. So there's many types of different methodologies. Also, you get longitudinal studies also in medicine. In social sciences, there's more the qualitative studies, the surveys, that kind of thing. So it's important for you to understand the different types of methodologies. What is also important, if you struggle to know which methodology to follow, it's always good to consult your supervisor. This is very important. And also to consult papers. You can learn a lot from papers that have already been published, but consult papers that were published in high impact journals in your field. So what do I mean by high impact? This is normally journals that have an impact factor of 3 to 4 and above. So if you see an article, if you find an article on the internet or on Google Scholar, on Science Direct or Scopus or wherever, you will need to go and check what is the impact factor of the journal in which this article has been published. Is it good enough? And then you go to the journal's website, and this information will be on the journal's website, and then you check. And then you look at the methodology that the study has followed. If the study is closely related to the work that you are going to do, then this will also give you guidance on what to follow and what previous researches have been done. Now, when choosing a methodology or also writing up your methods, this is where reviewers can critique you a lot. They will ask you, okay, why didn't you follow this technique? Okay, this technique that you use, for example, if you use the experimental analytical technique, it may have certain limitations. So why didn't you complement it with another technique? They will maybe critique you on your statistical analysis. Maybe you should have done different statistical analysis to compare your groups, or maybe your group size was too small. You didn't do a power analysis. So you can learn from previous researchers that published in high impact factors how to approach a methodology very well and ensure that you cover everything. For example, if you are a medical student or a social scientist and you're doing a survey, for example, if you're going to use participants, you need to decide how many participants am I going to include. For example, what are the exclusion and inclusion criteria? What are the confounding factors that may affect the outcome of my study? Will it be age? Will it be a specific disease that people will have? Will it be a specific location that may influence the results? So these are all small little things one needs to think about for your samples, for the techniques you'll be using, how you describe analytical techniques. For example, if you're doing surveys and using test batteries in psychology, if you're studying psychology, have these test batteries been tested for reliability and validity in a certain population group? So all these things one needs to think about and approach very carefully even before you start your study, and then obviously continue checking while you are doing your studies, because new methodologies are being developed daily and these are being published, and you need to stay up to date with this. Then the last point will be how to choose your supervisor and your mentor. Let me just go down here. So more specifically, so what do we want to learn from this whole activity today is what to consider when you choose your discipline. So there's a lot of things you need to think about when choosing the discipline. We'll be looking at that. Then obviously the different types of research, like quantitative research, qualitative research, where you will be doing more surveys and stuff like that. Quantitative research, where you will be using actual data. You'll be doing a lot of different statistical analysis on that. Different studies in medicine, as I already highlighted, and also very important, fundamental versus applied studies. Now, fundamental or basic science studies, that is where you want to answer a basic or fundamental science question. And this is very academically motivated. It's not very much applied, but you can use this knowledge of basic science to also do applied research. Okay, we'll be showing some examples of that later. That's also very important. Also, multidisciplinary research versus interdisciplinary. This is also important nowadays. It's important since we have such grand challenges in the world. We need to start doing multidisciplinary research, meaning if we're working in one discipline, we need to start collaborating with other disciplines to answer such complex questions. For example, I'm in nanotechnology. um, and nanotechnology is basically a mix of different fields. You need to know a little bit of physics, chemistry, and when you've synthesized these nanoparticles, you can apply it in different fields, in multidisciplinary fields, like for anti-cancer studies, as antibacterial agents. You can apply it in for solar energy. So there's a lot of different multidisciplinary fields one can then work on and collaborate with other people. Okay, this is important. And then also very important, like we already mentioned, choosing your supervisor and your mentor. Now, for the first session, or for the first part of the presentation, we will be looking at how to choose a topic and your discipline. Now, very, very important, even before you start deciding on a discipline, you need to understand what is being funded in your country and the rest of the world. What are hot topics? Have a look at the NRF research pages. What kind of research are now interesting? What is hot? What is being funded? And how can you see developing yourself in a field that will be funded throughout your career? Then also, you need to also think about other things as well, like, will my research be addressing some sustainable development goal? Also, applied research in terms of helping communities are also very important. So look at a problem in a community or an area where you are living and think about how can your research address that problem. For example, now in the country, we're having a problem with cholera. How, if you're in that specific, for example, medical microbiology field, what can you develop to stop the spread of cholera? Is there a specific sanitization agent that you can develop, that you can add to water? If you're in social sciences, how can you develop awareness of the dangers of cholera? If you are a medical student, how can you develop medications to treat cholera? So think about it like that. Then also there's other aspects also that you need to incorporate in your research. For example, many funding agencies or even fellowship applications now highlight and emphasize that your work needs to be gender aware. So there needs to be gender respect for gender the gender aspect. Okay, will you be including males and females if you're a medical or a social scientist? Will there be only females included in the study, and why only females? If only males, why is this, and why not both genders? So these are all things one needs to think about. Will the research be inclusive? We remember it's very important to do inclusive research. Also, what social impact it will have, and it will your work empower communities? How will it change the way we live? Will it address certain grand challenges like climate change or ecological degradation? Or will you do urban planning, for example, if you're an engineer, that maybe will promote a more green living in the society that will help with climate change? So these little things are all things one needs to think about. Also, when you do research, it should advance the knowledge. You should think about, is my research that I'm going to do novel? So what is novel? Is it new? Does it add to a body of knowledge? So that's why it's so important to look at the literature and see, has this already been researched? What have previous researchers done that has not yet been done? okay, that I can now do, that I can advance and progress the knowledge. Is my research international competitive? This is very important because it's important for your career also to attend and go to labs abroad, learn new skills, and then you need to do research that can be also applied not only here but also internationally. Again, very important is it scientifically rigorous? Can it be repeated? Is it ethical? Is it relevant? You need to also think about the who and the what and the where questions. Who will be involved? Who will I collaborate with? Will I be only collaborating locally, or I need to also collaborate internationally? This is very good for my career development, etc., etc. And what will I be addressing? So all these questions one needs to think about already beforehand. Then it's very important to also think about the sustainable development goals, that some of these be incorporated in your research, also our national development plan, some of the key challenges we need to address. Does your research fit in with this? Okay. Then you need to understand also when you look at the different fields, you need to understand what does this all encompass? What do people work on? With whom do people collaborate? So you can go to, for example, the UNISA web pages in a certain department, and you will look at, there will normally be a research link, and then you go onto the research, and then it will be subscribed. What type of research do people do? What papers have they published? And this will generally give you an idea of what people at a certain university are doing, um, where they're publishing and with whom they are collaborating. And for example, if you're now interested in chemistry, remember chemistry has a very, very wide scope. You can do materials research where you characterize materials for certain applications such as engineering, energy field, fuels, that type of thing. Also production of nanomaterials. You can more work maybe in inorganic chemistry where you look at chemical reactions, or you can look into pharmaceutical sciences where you develop certain chemicals and stuff like this, or chemical engineering. So the field of chemistry in itself is extremely wide. So understand the field and what type of research is being done in that field. Similar with life sciences, you get a lot of different fields. You get biology, you get biochemistry, that is extremely interesting. You get microbiology, you get genetics. So there's a wide scope of these, and some of these fields also link with interdisciplinary and or multidisciplinary fields. Then you also very important need to understand your institution. You need to understand the guidelines, the deadline dates. When is the deadline date to submit your honors proposal? You need to liaise with your supervisor. You need to understand what is the format of how you need to write your thesis, when is the deadline submission date, what areas of support are there for you. Is there an office where you can, that will help you to get funding or scholarships? If you are an international student, where there will be an office to help you acclimatize to your new environment. What types of support are there? Mentoring support if you are suffering from mental health problems. Many young people now across the world are suffering from mental health problems in science. And then you need to go and see, is there an office that can help you with these challenges? And so it's important to reach out, to understand your environment and not sit there and sit and worry and stress, but to reach out to someone, the supervisor, the mentor, someone to help you and guide you through the whole process. Okay, so understand the discipline, understand your institution, the rules and the regulations, the policy. For example, if you are an honor student, what is expected of you? Should you publish one paper, etc. Now, these are two good books that I would highly recommend you to go and read. It's Charting a Course for Successful Research Career. It's published by Elsevier. Samu has 2 copies of this that will be distributed to all of you, and also a PhD is not enough. Now, these 2 books, even this one on the right, the PhD is not enough. Read this already at the start of your career, and this learns you how to survive in science. There's a lot of different things you need to learn how to survive in science. Now, choosing a supervisor and choosing a discipline is just one thing. You will learn you will need to learn how to write papers. You need to learn how to publish. You need to learn how to manage your project. You need to learn how to manage yourself and what skills you need to learn. For example, you will not only need to learn experimental skills, but other soft skills as well, like emotional intelligence to survive in science, project management skills, leadership skills, all of this. And then also one day how to apply for funding, for example, how to present at conferences and all of this. Now, these books will all guide you through the process of um, how to look for mentors and how to look for supervisors and etc. etc. So have a look at these. And of course, like I also said before, remember my workshop is I can only put in so much knowledge in the hour that is given to us. But attend other workshops as well. There's lots of information on the internet, lots of information workshops internationally, locally. So attend as many as you can to grow your excellence. Okay. Then you also need to understand very early already, how does research work? What is the whole process? So first I will start thinking about what is a problem. And when I start thinking, what is this problem? Then I need to think about how does this address my country's goals? Will it address a community challenge? Does it address one of the SDGs, the Sustainable Development Goals? Is it inclusive? Is it ethical? For example, if I'm going to do a survey or medical research or involve any human beings or animals in my research, I need to apply for ethics clearance. This is very important. Even before I start my study, I need to submit my documents to the ethical office of UNISA so that they can approve it and give me an ethical clearance number that I will report in my study and in my publications, right? So this is very important. And remember, one needs to also think that of research that is repeatable. The work should be repeatable and reproducible by someone else. So first we start thinking about the problem. We have the problem now, and we now need to go and look at the literature to see what has been done about this problem. Or we can just look at the literature and get ideas. Sometimes in the papers, people will mention, oh, this is our study. We conclude that our study developed this technique, or this data showed this and this, but future work should focus on this and this and this, or there was a limitation of the study, and this can already give you an idea of work that you can continue. Now, next, we need to plan the study. So this is very important. What will my design of my study be? Will it be a descriptive study? Will it be a quantitative study, or will it be a qualitative? In medicine, you get different types of study design, so one needs to be cognizant about this also. Have a look at the literature also to get an idea of different study designs being done for certain studies. This is important. Will you do a randomized controlled trial? All of these things one needs to think about. Then planning is extremely important. For example, if one needs to do a certain experimental study, one needs to think, do I have the equipment? How much will it cost me to analyze the samples? Do my supervisor have the funds to do this? Do I have the chemicals to do my research? And then I need to order these chemicals already in advance, because this can take some time, and time is very important in science. One cannot waste time. So planning is important, especially also if you need a technique that is not here in South Africa. You need to think sometimes these to go abroad and do other techniques. There's deadline dates for proposals to be submitted. When is this deadline date? Is there funding? Can I get funding to go abroad? So all of this is very important. Then the samples. How will you collect samples? If you collect sensitive samples, how long will they last in the fridge? Okay, so these all things one needs to plan and think about when it comes to recruiting participants and collecting data. For example, if you are working with human participants, you need to start thinking now. I need ethical approval for my study if I'm going to be working on humans or animals. One needs to think about if I'm doing a certain study, for example, what will be my inclusion criteria for my patients? Which patients am I not going to include? And why not? For example, if I'm going to do a study, for example, on heart disease, I'm going to choose a certain group, but I'm going to exclude maybe people that smoke because this can affect or aggravate heart disease or lung disease or whatever. So some examples of this also, very important, how many am I going to include? What is my sample size to reach statistical significance? Now, some people do power analysis for this, which is also good. You can approach a statistician to help you with that. How am I going to collect and store my data? This is very important because remember, when we're working with scientific data, also we need to back this data up because something can happen to our computers. The computer may go missing and then all our data is gone. So one needs to back up this data, which is very important. Also, when we working with humans, we need to anonymize the data, right? And we need to also know who's going to have access to this data, right? Obviously, my supervisor needs to have access, but if you're working with sensitive information from patients, one needs to anonymize this. Also, open data is now very important. So when one publishes, one needs to put such open data in an open research repository. Normal journals will give you guidelines on where you can deposit this so that other people can also look at your data and maybe do other studies on this. So open data is now very important. Then one needs to think about also data needs to be analyzed to interpret the findings. Now, analyzing statistical analysis, there's sometimes a lot of problems with this, depending on which P level you choose. You may get statistical significance. There's a lot of bias in this. So one needs to discuss already at the beginning with the statistician, this is my data, this is what I want to do, what types of analysis can I do? And this is, remember, if you go to a statistician, don't just say, I want to compare group X and Y, and remember, your analysis needs to link back with your aim. It needs to answer your aim of your study. Okay? Then one needs to think already, okay, where my research results going to go? Obviously, I need to go to conferences. I need to present this. Publishing first is very important. So know the whole research process. First the problem, then planning, then starting the study, getting the samples, analyzing them, doing the statistical analysis, and then you distribute the information to the conferences and the publications. Okay, so this is the whole process, right? Now let's now look at understanding the steps in identifying the research problem. Okay, so first, one can outline your area of interest. So what field are you interested? Then you choose the specific area or the topic. Then obviously you have to narrow down your topic. Don't make it too broad and complicated because remember, for certain courses, you need to complete your study in a certain amount of time. For honors, it's a year. So choose a project that is manageable or a topic in 1 year. Then within that topic, you choose your problem, and then you identify, obviously, the purpose or the aim of your study, right? Once you have your problem, you will jot down the aims, the broad aims that you want to achieve with the study, and then obviously your specific objectives. Now, remember, there's a difference between an aim and an objective. Aims are very broad of what you will be addressing in general, and objectives is very, very much more specific. Like, for example, if you want to do a study on how soil microorganisms affect plant growth, you will mention something like My aim of my study is to test the effect of a soil yeast, and then you name the genus and the species of the yeast or the microbe you're going to work with on the plant. And then remember always to be specific. Don't just say, I'll be doing a study on how yeast affect plant growth. Which yeast, which plant, how the growth will be affected. So this will be your general aim then. My study is on how the yeast will affect plant physiology, and then you look at the specific objectives. So the first objective will be, for example, to isolate the soil yeast and identify and molecularly identify. The second objective will be to test, for example, the effect of the yeast on photosynthesis and growth of the plant, right? And maybe the last objective will be test the effect of the yeast on the elemental content of the plant, something like this, or the biochemical compounds of the plant. So your aim is then broad to test the effect of the yeast on the plant physiology, growth physiology, and then you narrow it down in your objectives. And your objectives should link back to your broad aims, okay? Then also, as I said, read widely, talk to colleagues. This is important to develop a topic, find out what others are doing, and ask questions. At conferences, ask questions, talk to people. This is also how one gets ideas if you have the opportunity to attend these conferences. Now, very important, remember this, it is really important to do the right research as well as do the research right. Okay? You need to do wow research, research that is compelling and not just interesting. You need to do research nowadays, especially to get funded, that is wow, that is multidisciplinary, and that has some applied component and some SDG component. Okay, remember that. Besides also, it's also important, besides only doing applied research, it's also important to do fundamental research, basic science, because this leads to answers that can be used in applied studies. Okay, choose very carefully. Remember what I said earlier. You need to be passionate about this. This will be part of your life for many years to come. Maybe you'll decide to change to another discipline if you don't like what you're doing currently. It will define also your job area, and you may be working in this for some time to come. So choose very, very carefully. Okay. Then also ask yourself, again, coming back to topics, is the topic well funded? Your supervisor may also suggest a specific topic to you that he or she will be able to assist you with. You can also assist or select your own topic that you find by reading journal papers, okay? And again, on this choosing the topic and the discipline, first you'll be choosing a general subject area, and then you will be narrowing it down to the specific issue, okay? Then now in general, let's look at now in general, getting ideas for topic. This is a bit of a summary. So as we already said before, conduct the literature review. This is important. If you have questions, approach the authors of the paper. Look at the section, the conclusion section. There you can find a lot of details of recommendations for future research or current limitations of a study that can give you ideas of other studies that you can build and work on. Ask yourself what is known about a field, what is not known. What was the approach to the study problem when you look at these papers that have already been published? How did they approach this? What methodology did they use? Search the internet, funding bodies also, projects that have been funded. The news sometimes can also give you even ideas about research areas that you can focus on, like, for example, now the challenges with cholera. You can check research websites, for example. Now, sometimes there's also events in the world that happen that give people ideas for research. Now, like the COVID pandemic, that gave rise to a lot of different research topics in microbiology, immunology, psychology, social sciences, medicine, even climate change. So sometimes there's these events that happen that give you ideas. Interact very importantly with your senior staff members, your postgraduate students. You can even build a mind map of your ideas and then try and link it all together and then find a specific niche area for you. Build your academic networks, attend presentations. There's a lot of departmental presentations and webinars that are usually advertised. So go and attend this and have a look at what is being done and how you can contribute to this. Okay. Now, thinking about topics or thinking about what research I'm going to do, creativity here is also very important. So the conversations that you'll be having at conferences. So be creative in how you think about potential topics, right? Talking to strangers at conferences in your immediate networks are very, very important. Sometimes talking to people outside your field can even give you good ideas. I remember once I'm a biologist essentially, but I was once talking to a physicist, and this person gave me a complete different look on my specific work that I was doing. And this gave me also interesting ideas, creative ideas to further the work. Okay, so be creative. Then some people follow certain models. Now, it's not necessary that you follow these models, but this is just some guidance of how to get ideas. Some people will wake up one day and they will get an idea. For some people, this really happens, but for some, it do happen. So always have a type of notebook with you. For example, if you will attend a talk, have a notebook or your phone, even you can make notes on the phone or on a notebook that you jot down all the things you learn or your ideas, and then you can later go back to that. So then there's another type of model also. They call it the apprentice model, where your supervisor will give you ideas. But this is important then that you are interested in this. Don't work on something you find boring or badly motivated, and check that there's not other people also working on the same thing. This is also, they call this the Phoenix model. You work on some projects and think very hard about what you've done, looking for insights. This is when you already have working on some project. This is also a type of model. But like I said, it's not necessary to follow these models. These are just examples of how people get ideas. Sometimes people will work already on a project and then they will get further ideas for this. This is also synthesis, where you read some papers and then you find some ideas, but be careful also. This is the thing with looking at the literature. There's a lot of literature out there. So when you look for information, use your keywords very carefully, because depending on the keywords you use, for example, if there's a topic or a field that you're interested in, sometimes you have common keywords in this field, or you can also find articles and then they will normally list keywords that are commonly used in this field. But use this carefully, because this will determine what kind of information you retrieve. Sometimes it's good also to go to a librarian and ask them how to construct a search string to get specific types of information. They can also help you with that. So then this is also example of some other models. I'm not going to detail into this now. This is just how some people come up with ideas. Now you need to convert your ideas, obviously, to start your studies. You've now selected your topic, and now you can, it's also sometimes innovation in research is also important. How can you innovate an idea? Even if your supervisor gives you a project, you can also think on how to make it more innovative or more interesting, more applied, and then you can discuss this with your supervisor that you like this topic, but you would like to tweak it here and there and ask for their feedbacks. Also think about what I said, is the topic appropriate for the discipline, or can it be applied to multidisciplinary areas? Obviously, then you need to identify your supervisor, or already you may have a supervisor, and then you just focus on your problem, and then you narrow down your topic. For example, if you have a topic like, for example, unemployment in India, it is very, very broad, this topic. In which sector? You need to ask yourself, in which group of people, in graduates, in adults, for example. So always narrow down your topic, always be specific, okay? Remember, there's also a time limit, so you need to finish your degree in a certain time limit. Now, when you have your topic, you also need to start asking questions, or even before you select a topic, you need to ask certain questions. What is going on in a field? Maybe there's a key word that you don't understand the meaning of, or sometimes disciplines also have certain subject words that you need to understand. So understand the meaning of this, understand the processes being followed, understand, for example, if you are, for example, a medical student and you are investigating a certain disease, and for example, then you need to think about what factors in my patient group can influence the incidence of this disease. Which patients should I exclude that may give me confounding results? For example, how effective is the technique that I'm going to use? For example, if I'm going to use a certain um, experimental analytical technique, how do I need to prepare my samples? How long should I keep my samples in the fridge, for example, before the compounds or the biochemical compounds I'm looking at will start to degrade? Is the technique that I'll be using reliable and valid for my type of samples? Ask also the questions, who will be involved, what will be done, where it will be done, and when. Okay, so ask questions, innovate. Um, Remember, solving a problem that exists is not advisable. You need to do novel research. You need to do something that is unknown. Don't do something that someone else has done and you just repeat it. Think out of the box. We need to do grand research nowadays to get the funding, right? Then also, very important, now that we have our topic, does it make a contribution to the science? Is it practical? Can it be applied to the industry, to community, to communities, to policies? What societal impact will it have? Will it have some personal relevance to me? Then very important, will the project or the topic be feasible to do in the time that I've been given to me to finish my degree with the funding that is available? So think about this as well. Ethics is also very important. If we remember what we mentioned before, if we were working with animals or with humans, if we're doing clinical trials, retrospective reviews, where we will just be looking at summarizing data in patient files to get an overview. For example, if we are looking at psychiatric patients and we want to see what drugs they maybe have used that may have contributed to a specific illness, then we look at their patient files, and this will generally be minimal risk research. Then you can ask for expedited ethical review. But if you're doing a clinical trial, it's a bit more sensitive, so we need the ethical clearance might take a bit longer. Okay, so also very important, will there be risk to the environment or to yourself? Are you going to work with some dangerous chemical? Then you need to be very much aware of the material safety data sheet of this specific chemical. This you can find on the Sigma website. Very important. Then you need to protect yourself, wear the gloves, the mask, the whole protective gear, so that you don't expose yourself to something that will harm your health. Also, ethics again about data confidentiality, especially when you're working with humans, you need to anonymize data that is sensitive. Okay. Also, you need to think: is my research moral? Is it inclusive? One needs to think about that. Very important also, research integrity. Don't fabricate data. This is very important to be cognizant about research integrity and research reproducibility. So will someone else be able to reproduce my work? Hence, when I describe my methodology in my thesis, it needs to be clear enough for someone else to repeat it. Okay? Then other questions to ask yourself now. Are you fascinated by this topic? Do you have the necessary skills to do this topic? If not, then you just attend workshops to get the skills. Can you complete the project in time? Will the research still be current when you finish? Do you have sufficient financial and other resources to complete this? Will you be able to gain access to the data? These are all things one needs to think about. Again, ask yourself, will the examining institute standards be met? Okay, this is why I mentioned understand your institutional environment. Does the topic contain issues with clear links to theory, for example, or to society? Are the research questions and objectives clearly stated? Will the proposed research provide fresh insights into the topic? Are the findings likely to be symmetrical, reproducible, and does it match your career goals? So these are all types of questions. Are you passionate about the work? Can this interest be sustained? Because remember, when you're really passionate about something, the work comes easier to you and you deliver more. Is the problem solvable? Also ask yourself. Is it worth doing? Can it lead to other problems that I maybe can do my master's in? Is the work manageable in size? Does it have potential for making a novel or an original contribution to the literature? Again, ask yourself if the problem is solved. Will the results be reviewed well? Because remember, when you have to publish, the editor will want to publish work that his readers or the journal's readers will read and find interesting. So have a look at that also. So that's why I said already at the beginning, have a look at journal articles and what do people publish? What are people in a specific field interested in to read, right? As I said before, if you lack certain skills, gain these skills. It's not a train smash. If you don't have the skill, then you just learn it. Okay. By solving it, well, you have demonstrated independent skills. This is very important skills that you will one day use in your future job. You may want to go further into academia or you want to go into industry. Did you learn some skill that can help you with that job application? Did it prepare you for your further research career? So now in sum, if we're looking at how to find the topic and the research area, let's look now in sum about this. So you can conduct a literature review, obviously research the internet. The news is also having full of ideas that you can have for generating future research ideas. Remember to build your academic network. Be creative when you're tackling a specific topic or you're choosing it. Be creative, be innovative. You attend those seminars. There's a lot of conferences. Attend this if you have the funding. Check the university websites. Look for the limitations in previous research. Also, what problems are communities facing or industries that you can solve. Then when you finally have your topic, you have to think about all these questions that you have to ask yourself. Does it link up with the sustainable development goals? Does it interest me? Is it feasible? Do I have funding? Do I have access to the chemicals or the techniques that is required to complete the study? Is it ethical? Is it practical? Topic of interest to the discipline. Is it of interest to you? So think about all of this. And then again, in some, you can use this friends format. Is it feasible? Is it relevant? Is it interesting, ethical? And is it not too broad? What is the discipline and how does it link up with your supervisor's knowledge, interest, and stuff like that? Okay. Also, when it comes back to relevancy, also how does it apply to the world out there? Is it going to make some difference to some community? Is it going to address a sustainable development goal? Very important, this feasibility. Can I finish it in time? Okay, do I have the financial means to finish this project, or do my supervisor have the financial means, the funding to in order for me to effectively finish this? Where's the equipment? Is the software available, for example, for me to analyze my data? Is it available freely? So one needs to think about all these little things when choosing a topic. Now we're done with that. And now we're going to move on to the types of research, right? So now we've discussed how to choose the topic, how to choose the discipline, and now we have our topic and our discipline. We've made our aims and our objectives, and now we need to think also, we need to understand also the types of research. Now, like I said before, there's lots of different research types. You get the basic science research, you get the applied research, where you address some problem in the industry or for the community, where your research can really answer a grand challenge or solve climate change. Then you get the qualitative. Now, in some of this types of methodologies is also linked to specific disciplines, like social sciences will have more qualitative research, also maybe medical sciences, whereas the pure science field, like life sciences, etc., physics, chemistry, engineering, will have more quantitative research. Okay. Here's again a summary of the different research types that you can have a look at in your own time that we already discussed: qualitative, quantitative, descriptive studies, whereas also you get analytical research, where you use more analytical approach to answering questions. This is more in sciences. This applied and fundamental can also be not only in the sciences, but also in social and in medical sciences. There's also, if we look at the design of the study, it can be exploratory versus conclusive, or the data type can be primary or secondary research, where you reanalyze already existing data. So this can be stratified by the data type, the design, the general category, the nature of the study, and then, of course, the purpose of the study. Is it applied or fundamental, right? Then analytical research, if we do that, it can be something like a cause and effect, where we analyze something, primary versus secondary. So what do I mean by that? For example, if one does for example, in medical studies, one gets a lot of systematic reviews and meta-analysis. So that is where one have a look at what has been done in a specific medical field. Then you do a very rigorous review of the literature following a certain methodology. So, for example, you will be looking at specific websites. You will be looking using specific keywords and dates of the studies, and then you will report in the methodology of your studies. And then you will retrieve the data from these studies, and then you will do a meta-analysis, that is some secondary statistical analysis on the studies, to see the outcome of what has been done. And these types of works are also very important to advise the evidence base in medicine, right? So this is an example of a secondary type of methodology or secondary approach. There's also the deductive versus the inductive reasoning, aims to developing a theory, while deductive reasoning aims at testing an existing theory. Then you'll also get conceptual versus empirical research. For example, conceptual research includes unique thoughts and ideas as it may. It doesn't include any experiments and tests, where empirical research includes phenomena that are observable and can be measured. So you're actually working with actual data points. Then one also gets conclusive versus exploratory, and this refers to the investigation of a research problem that is not clearly defined or understood, whereas conclusive research is a type of research that is used to yield information that helps reach conclusions. Then qualitative versus quantitative. Quantitative works with your measurable data, whereas qualitative studies rely on personal accounts, documents, or surveys in detail that describe how people think or respond within society. So these are different types. So there's many different types of research methodology that can be described by the type or the design, etc. If you are struggling to understand this, your supervisor can also assist you and look at papers of also how they describe their methodology, okay, in your specific field. Then also you get descriptive and analytical, for example. Analytical focuses on cause and effect, and descriptive research classifies, it describes, it compares, and it measures data. Then you also get the exploratory versus conclusive. The surveys that you will do, for example, maybe you will want to do a survey of students' experience completing honors degree. Then you will do a survey of how to test the time in which perhaps students have completed the degree, or the level of happiness when they complete the degree, something like this. Case studies is something a bit different. This is in the medical field where, for example, you have a specific case. For example, you have a patient that has a severe reaction to a specific type of medication, and then you report this as a case study. Now, this is very important and very informative. So when doctors have experienced certain very specific cases, then they can go to these case studies and have a look at, do I have a patient, or has this been previously published, so that I can consult this knowledge, and this will guide me on how to effectively treat the patient. Sometimes you also will get very specific types of reactions, for example, to a specific medication, or a very specific case, for example, where a patient has a unique reaction to a disease, and then they describe this. For example, in inflammatory bowel disease patients, one doctor noticed that a patient's hands started swelling, and he reported this. And now people with this type of disease can go back to these types of studies and see, okay, if my hand starts to swell, it's normal. It's related to this disease. Now, this is more also again in the medical fields, this longitudinal studies where you will be testing medicine across a long-term stage. For example, if you're doing certain clinical trials, you want to test certain medicines over a long time period, and then you would look for adverse effects or responses to such medication, or clinical trials also where you test the efficacy of a new medication. This is just, again, the descriptive versus analytical. The most important actually for you is to learn that it's important at the very early career stage to already do applied research that can make a difference in society. But it's also, remember, fundamental research underscores normally applied research. So fundamental research is concerned with the formulation of a theory. It is an add-on to already existing scientific knowledge, and you can use this basic scientific knowledge to do applied research. For example, if you're looking at how, for example, soil yeast will affect plant growth, then you need to actually do basic science research. Now, this will, for example, involve at what is the mechanism of how the yeast promote plant growth. Does it produce some kind of biochemical compound that dissolves nutrients in the soil? How are these nutrients taken up by the plant, using which pathways? So then you fundamentally understand how the yeast affects the plant's growth, so that you can use the yeast as, for example, a biofertilizer in applied research, where you apply it to a plant and then see, does it really promote the growth of the plant, or increase the seed production of the plant, for more applied studies. Okay, so here again we focus on different types of studies. You can or different types of methodologies. You can go through that in your own time. Again, qualitative and quantitative research. I'm not going to go into detail about that now. These slides will be shared with you, and then you can go through this. I would like more to focus a bit on this basic versus applied research. So what is the difference between the two? So the purpose of the basic research, as we already discussed some points, is to expand the knowledge base of processes For example, if you're working in the business field. So here's just a summary of this. And then, for example, the purpose in basic research will be to expand knowledge of processes of business and management, whereas the applied part of this type of approach will be how to improve the understanding. Okay, so this is very important for you to understand. Also, the timelines that this takes to develop. Yeah, again, there's some examples of basic versus applied research. Okay, this is important for you to understand, but I already gave you some examples. Here are also some good examples. Remember, basic research expands the current knowledge, whereas applied research solves particular life problems using knowledge from basic research, right? Basic research is more theoretical and exploratory in nature, whereas applied is more practical and descriptive. Basic research can sometimes have a wider scope, whereas applied have a more specific scope, right? Basic research is less associated sometimes with technology, and applied is more with the advancement of a technology. For example, if you are wanting to test the effect, for example, uh, of, first say, for example, you want to develop a nanoparticle to be applied in a solar system, then you need to think about what physical-chemical characteristics of this nanoparticle lends it the specific property that will help it to promote its activity or application in a solar cell. This will be the basic science. And then you actually will go and incorporate this type of material into a solar device and see if this really works. So this is the applied research component. Okay. Let's look again at the differences. Um, Basic is not really connected to economy or technological advancements, where the applied research is more, etc., etc. Right? Here's some more details. Here's some examples of fundamental versus applied research. So you can read this example here that has been published. For example, this one elucidating the wound signal mechanism in fresh cut produce, scientific implications and opportunities for practical applications. So they did basic research basically on what does the wound signal mechanism entail for it to be applied into some applied research or some applied aspect of research. Okay, so also here's another example that you can go through in your own time, and this is also a very important besides now applied and fundamental research, one also needs to have the multidisciplinary component, and that is basically collaborating or working on a topic that encompasses different fields, where you collaborate with people from different fields to answer a specific research question. And this is very, very important nowadays because we have these grand challenges and we cannot fix such problems by being working in only one discipline. Like I gave this example of nanosciences. It's a very multidisciplinary field because you have to have expertise from physicists, from biologists, from chemists, from material scientists to understand a nanomaterial. And this can then be applied in cancer research, in antibacterial research, in energy research, in fuels. So this is the idea basically behind doing multidisciplinary research. And go and read this article here in New Scientist. It will give you some insights on how to open your mind to interdisciplinarity. Okay, and this diagram just explains the difference between multidisciplinary research, where you have your research problem and it's surrounded or it's advised by different disciplinary theories. And here you have the interdisciplinarity, where you have your research problem and then it's more intersected by the different disciplines. You also get the transdisciplinary research that is a bit more complicated. Now, in the literature, there's been different definitions for interdisciplinary and multidisciplinary and disciplinary research. So have a look at that. Disciplinary research is more where you focus on your own field. Multidisciplinary is where you collaborate with different researchers from different fields. For example, you're a physicist and now you collaborate with biologists or chemists or cancer researchers, for example. If you're doing, for example, radioisotope research and you're working with cancer researchers, this is also a form of multidisciplinary, whereas interdisciplinary is more, for example, scientists working with social scientists, for example. Then you cross different disciplines outside of science. But as I said, the literature has different definitions for this, okay? Here's some examples of transdisciplinary research where you have a whole mix of different challenges. You have your societal problem, you have your scientific problem, you use new knowledge, and then you disseminate this knowledge, and this all overlaps with defining your sustainability problem. You're producing your new knowledge and you're assessing the new knowledge. So transdisciplinary is a bit similar to interdisciplinary, but there's different definitions for this. Here's some examples of how it all interlinks. For example, if you're working, for example, in the built environment, say, for example, you are an urban planner. Then if you're wanting to do, for example, a multidisciplinary study on how to build more greener spaces, then you will have to collaborate with engineers maybe. If you're going into interdisciplinarity, then you will add business as well, because this will be a bit outside of science. So you can link up different fields to form a really nice and multidisciplinary topic. For example, here, the natural environment also you can incorporate natural sciences in this. But for example, if you're working on for example, pollution in the environment, this can be also multidisciplinary, because pollution can affect agriculture, it can affect animal health, it can affect people's health, it can be a risk to the environment itself. So this is how you can make the study more multidisciplinary. Okay. There's some more examples. So if you really think about it, science and research is really very much interlinked, right? If you look at medicine, it's also somehow interlinked with psychology, social studies, infectious diseases. Even sometimes clinicians tend to work in their own field, not so much with scientists. And this is a great danger in the world now, because if you are, for example, working on infectious diseases, you need also a scientist or a microbiologist to understand how the microbe works and how it spreads and what is its mechanism of infection. Not because if you understand that, then you can better treat the patient. Okay, so these are just some examples here. This is another example, tips for developing interdisciplinary socio-ecological researchers. For example, nowadays, if you are working in ecology, there's now a trend to involve citizens in your science. So you can involve citizens to collect science. This is also a form of interdisciplinarity, where you collaborate a bit outside of your field, where you involve other people also to get involved in ecology. Here's also another example, multidisciplinarity, interdisciplinarity, and transdisciplinarity in health research, services, education, and policy. This is a nice article to read for you to understand the differences between these types of approaches to doing research and collaborating. Now we're done with all this. Now we have discussed how to choose a topic, how to choose a discipline, and we've discussed now the different types of research that there is to do. Applied and fundamental is the most important, and then the different types of methodologies, qualitative, quantitative. In medicine, your case study, your longitudinal study, your retrospective review, where you will be more looking at clinical files. We've discussed now all of this, but now very important, how to choose the supervisor and the mentor. Now, sometimes supervisors will already have a topic that you can fit in with, and then you go to them, you discuss that you're very interested in this topic and you would like to join their group, etc. Or you can decide already on a topic and go to a potential supervisor and say you would like to do your honors, or your, let's say, for example, now on the honors, you would like to do this. And if they have space for you in their lab, if they have funding, and if this project will be feasible, right? So this is one approach that you can use. But you also, when you approach a supervisor, it's also advisable to mention to the person what skills can you add also to the lab. What is your background knowledge? For example, do you have background in biochemistry? That can be very beneficial for this lab. Maybe there's no one else that has expertise in biochemistry. So offer also the benefit that you will add to this environment. Right? Now, choosing a supervisor can be sometimes someone can become your supervisor. For example, you may have a mentor that you decide, okay, you trust this person. This person has a lot of knowledge in the specific field that you are interested in, and then they can eventually become your supervisor. Sometimes you will be maybe doing some internship in some lab or some holiday work, and then you can learn also how the lab environment works, what equipment is available, the supervision style, and then you can decide, okay, this may be a good supervisor for me, and then you can approach the person. Then also, you need to ask yourself also when you're selecting a project or a supervisor, is this project worth doing? Like we already said, will it be finished in time? Does it address some sustainable development goal? Does it solve some societal issue? Will it be completed in time? Very important. Can the supervisor help you? Do they have the knowledge to guide you and help you effectively complete this project? What is the institutional environment where the supervisor is based? How is this environment for you? You need to understand this also. What are the workshops that are being offered? What are the support that is being offered? Are there a bursary offers? Things like these. Really, is your project the institutional priority? Sometimes, besides the goals, the sustainability, the development goals, and also the country goals, institutions may also have certain goals for research that they focus on. So does your research focus with their aims and their vision of research that they want to do? Very importantly, is there money available for you to personally sustain you and also to complete your project? Does the supervisor have the equipment for you to work on? Who is the supervisor working with? Is he working with national researchers, international researchers? This is good because then you can maybe visit a collaborator's lab and learn a new skill. So think about all of this. Then also understand the difference between supervision and mentoring. Now remember, a supervisor is a person that will lead you and will guide you to finish your thesis, right? So they will assess your performance along the way. They will have some kind of agreement with you where you have to provide feedback of your progress. So this is a general role of a supervisor, to supervise you, to guide you, to ensure that you progress well, and to be there for you if you have uncertainties or questions, and for you to effectively in time finish your project and eventually graduate. Now, the supervisor can also be your mentor, or you can have someone else to be your mentor. Now, the mentor is there to provide you with career and social support to help you with your career, to provide opportunities for you to enhance your network, and also to learn you some soft skills like leadership or project management skills. This is a person that will want to see you grow and succeed. So this is very, very important. What career decisions you make, how to solve problems, how to set your goals, for example, help you with setting up your project plan and your goals for what you see yourself or envision yourself to achieve with your project. So this is the difference between the supervisor and the mentor. But the supervisor can also be a mentor, or the mentor can be someone else. Very important, choose your supervisor carefully. In your honors degree or in your PhD, in your master's, this will strongly influence the success and quality of your degree, right? It is vital that you choose the right supervisor. Sometimes the wrong choice can be a bit deleterious to your career. So choose this very carefully. That's why it's always good to go on internship, go and do an internship in a lab and find out, or do some holiday work in a lab, find out what is the environment like, what is the people like, what is the supervisory style like. Do you see yourself fit in well here? Do you have a skill that can add to this environment? Very, very important. You can also attend seminars, and then you get an idea of what people are doing, what their labs are like. So choose very, very carefully, right? Sometimes it's good to align your research interest with that of the supervisor. And remember what we said is you have to do something that both you and your supervisor is interested in. Now, once you have targeted someone, go to their personal website or their group website, see what do they publish, who they collaborate with, um, all these things. Go to the group website, go also attend webinars and seminars, and as I already mentioned, go and visit the lab, go and speak to people there, find out what is the environment like and what instruments, for example, is available for you to do your work, right? Now, let's look at some rules and some more advice. Now, you can choose a supervisor, can be someone that you admire, someone that you met at a conference. Okay. You can also ask your mentor if they can recommend you potential supervisors or if they can be your supervisor. Okay. Then again, very important, you need to align your expectations with that of your supervisor, right? What is your goals? What is their goals? What is your working style? What is their working style? Do they have funding for you? Very, very important for you personally and also for you to complete the experiment, okay? Are there any opportunities for professional development? Will you be able to go to workshops, to conferences, even abroad to broaden your skill set, to also broaden your soft skills or learn other new techniques, or be in different environments, which is also very good for your personal development, right? What is expected of you in terms of publication? What is this you have to already start discussing at the beginning. How many papers are expected of you to be published? Now, already very early on in the career, it's important for you to publish. Publishing is extremely important already at the honors phase. So try, and when you finish your work and your study, try to publish this, right? Ask yourself also questions. What are you looking for in your supervisor or your mentor? Remember, people differ in their supervision style. What are you looking for? So ask yourself, um, what what do you want in this relationship, and what can your supervisor give you? Remember, this is almost like a relationship. It's like a partnership. And often if you go on to masters and PhD, you form a lifelong bond with your supervisor, and this person can really develop your career and guide you to be a successful scientist or job applicant one day. And ask yourself, what do you seek to get out of it? Remember to keep in mind that a large portion of research is conducted by the PhD student, so you're also an asset, right? Your supervisor is there to provide you guidance. So already from the very, very early career stage, they will provide you with guidance. Think about what is their work style. This is important. That is it compatible with yours? Um, Talk to students. Ask them, how often do you meet? Also ask your supervisor what is expected. How often should we meet? And remember, you also need to chase your supervisor. You need to ask them. If you're struggling with something, you say, please, I need a meeting. I'm not sure, unsure about something. I need help with writing up my thesis, etc., etc. So approach them. Remember, supervisors can sometimes be extremely busy, so you need to also reach out to them, and you need to have regular meetings with them. Also ask them what is the turnaround times for when they will provide feedback on a paper. Sometimes, again, supervisors can be busy, very busy. So give them on early on already small draft sections of your paper, of your thesis, so that they have enough time to review it. Ask them, what is the lab culture like? You can also ask people in the lab, how does your supervisor react to mistakes or unexpected results? How does your supervisor react to interruptions, for example, in your personal life? So these are all the types of questions that one needs to think about when choosing a supervisor. Meet the past students, ask them what were their experience like, were they happy, were they unhappy, why? And then remember, consider the entire experience, okay? Again, when you are selecting someone, trust your gut. Learn to know this person, learn to know their supervisory style, and trust your gut. Okay, what does your gut instincts tell you? Well, this person will be a good match for me. Will they develop my career? Will they help me when I need them? Okay. This is also a nice article in this plus computational biology. So have a look at this article, 10 simple rules for choosing a PhD. This will also apply to honors students. So whenever you're selecting a supervisor, also have a look at this. Then there's a lot of information on the internet. For example, this one here, choosing a research project and a research mentor. This is a very nice article to go and read and see how do I choose my project and my mentor. So there's a lot of articles on there. Then also you can develop yourself. When you are now having your supervisor, you develop a checklist, for example, for yourself already at the honors level. You will ask yourself, obviously, will this, you make a checklist and then you ask yourself, for example, will my study, this type of study, can it be go beyond honors and go into a master's degree, for example? Is there funding available for me and also for my project? How many papers should I publish? What is the length requirement for my thesis, the format? Ask your super whether the supervisor will correct the thesis before submission. Do you need the supervisor's approval before submission? Of course. So all of these questions, jot this down and ask this to the supervisor. How many times a month or a week should we meet? What is expected of me? Also, when one day when you're doing your defense, how long should my defense be? What types of questions can be anticipated? Remember to meet regularly with your supervisor. If they are quiet, they may just be busy. So reach out to them to have regular meetings and feedback about your work. This is important. If you're experiencing troubles, with your work, if you have experiencing challenges or experiment is not working, then you need to reach out. Don't sit there and stress. Reach out to your supervisor. Ask them, this didn't work. What could I do differently so that my experiment can work and that I can progress? Now, as I already mentioned, it's very important for you to choose a mentor also. This is someone that will help you develop professional connections. You can also ask them for a letter of recommendation. They can give you honest feedback about your strengths and your areas that you need to improve on. For example, maybe you need to develop your leadership skills or your project management skills. They can also help you with identifying opportunities or resources, and they can also support you in finding a potential job. Then mentors can be found really anywhere. It can be found at conference. Sometimes you meet someone in your field at a conference. It can be a postgraduate um, student also, but reflect on whether the mentorship is the right fit for you. Why do you need a mentor? What areas in your personal life and in your career do you need to develop? And will this person well fit the needs that you need to develop? Right? Identify your needs, as we already mentioned. Also consider people that you admire. You can start with your network, your postgraduate students, your supervisor, some other colleagues that you trust and that you feel comfortable to go to for advice and support. Um, you can also sometimes there's also international programs or local programs that offers opportunities for being mentored. Um, Also, for example, when you want someone as a mentor, you can develop what we call an elevator pitch. So when you approach this person, have a nice um, overview of what you do and what your life goals are and where you see yourself in 5 years, for example, already summarized as an elevator pitch so that you can pitch, this is me, this is what I'm doing, and this is where I want to develop myself, and hence I require your assistance or your guidance as a mentor. Again, like with your supervisor, you need to meet regularly with this mentor. You need to have a monthly or a weekly meeting. It can be a phone call. It can be an in-person meeting where you discuss your progress or some stumbling blocks that you experience or some advice. For example, maybe a paper has been rejected and then this person can advise you how to improve the paper or which journal next you should choose. Then also, when you look at the mentorship relationship, um, you need to set goals for this and you need to form a personal bond with this person. And if you receive criticism, don't take it as negative, take it as constructive criticism to develop yourself. You want to meet regularly, you want to create agendas for the meeting, and you want to update them on your status, where you are at your experiments or in your studies. Are there any problems you're experiencing, etc.? Be honest with your mentor. Always share helpful feedback. You want to set, and also sometimes you want the mentor to be your lifelong mentor or only for a couple of months until you finish your degree. So set also some boundaries for that. um, when during the meeting, take notes, or you can also record the meeting, but first ask the person's permission. um, Practice gratitude. You need to be thankful to this person. You need to really appreciate them for providing their time and their effort to help you, right? So really mentoring is there to train you, to motivate you, to provide advice, to see you develop into one day a successful person, to provide direction for you, and also emotional or personal support should you need it. Okay, there's some tips for mentoring. One day you may also want to mentor someone. So sometimes you need to have a lot of patience, a lot of perseverance, some coaching ability, very importantly, empathy with a student's situation. This is very, very important so that you can understand and help them. Now, let's look at the overall summary of what we've been discussing, because I see we're running a bit out of time. So understand when you're choosing a subject or a discipline or a topic, understand the country goals, the sustainability development goals. What is your institutional vision for doing research? Allow yourself to fit your goals in with all of this, right? Does your topic address, for example, one sustainable development goal? Does it link with your supervisor's interest, and does it link with your country goals and also with your institutional environment? Also, very importantly, can it be applied? Will it solve some societal problem? Look at this friends model when you're choosing the topic. Will it be ethical, relevant? Will you be able to um, finish it in time? Will there be funding for you to complete this? You need to also be cognizant about the different research methodologies and the types. It's also very important to do multi and interdisciplinary research nowadays because we have grand challenges and we can no longer only be working in our own discipline to address some of these challenges. And very important, when you choose your supervisor, go and have some work shadowing or some internship or some time in the lab so you can understand the environment, the supervisory style, the techniques or the equipment that is available to you, and learn to get this person, what type of research they do, their personality, and if they will be a good fit for you. Also, very importantly, having a mentor is extremely important. So, right, this was quite a mouthful, but these slides will be shared with you. And if you have any questions, you're most welcome to reach out to us and ask us. So thank you very much for listening.